8th grade. It's Mrs. Painter here. We have been talking about electrostatics, and so just to remind you what we've been learning is electrostatics is this field of study that has to do with electricity that is stationary on an object. And so it stays on top of that object unless you can get it to move. And that's what today's lesson is about. Today we're going to talk about how do you transfer electrostatic charges. So you have two options here of how you can transfer, and they're found in your textbook on pages 314 to 318. That's your reading for today. If you haven't done so already, you can pause the video and read, or you can do it after we're done here. But please read. There's also the questions at the end of the chapter that you can do for homework for me. So make sure you get that sent in, take a picture or scan it and send it my way, okay? But anyways, there's two ways that we can transfer charges, and one of those is induction and the other is conduction. And if you remember from when we talked about heat transfer back in like chapter 5, we talked about that one of the ways that we can transfer heat is by conduction. And if you remember what that meant, it means that you can transfer it by direct contact, directly touching something. So when you transfer an electric charge by touching, okay, by direct contact, or conduction is the scientific word, it is permanent, okay? So the reason it's permanent is because when you touch, the electrons can literally go from one object to the next object. So they transfer. But what you have to remember is this whole idea of the law of conservation, right? So the law of conservation says you can't create or destroy energy. The same is true in regards to electric charge. You can't lose electric charge. The total charge, like what you start with on the one object, is going to be the total number at the end after touching is going to be the same, whether they share it or it completely goes to the new object. Okay, so that's the law of conservation of charges. Because electrons can't be created or destroyed, right? They can only be transferred, which we've gone over and over and over again. One thing you can do, it's pretty cool, it's been super helpful in our modern society, is this concept of grounding. Now, if you've heard of grounding before, or maybe you've seen these antennas and whatnot at the top of really tall buildings, okay? What they're doing is they're diverting electric charge from up on the top of that building down into the ground. So that's why we call it grounding. So that electric charge can travel down to the ground, and that electric charge can then go into the earth. And because the earth is so large, it has a way of neutralizing that electric charge. And so that's why we have those on the top of really tall buildings, because when electricity or from the lightning hits, then we don't want that to go to the building. We want it to go to the ground where it can be neutralized, okay? So if you look on page 314 in your textbook, you're going to see some pictures, okay? And there's a rod that has and then that has no charge, and then there's a negatively charged ball. And when you bring the ball close to the bar and you actually touch the bar, then the electrons that were in that charged ball can travel to the rod. And now both the ball and the rod are charged, okay? That's conduction because they've actually touched. Another way you can do it, though, is by induction. Now, induction simply means that it's being the charge is being imparted from a distance, okay? When this happens, you're producing two charges, and it is temporary, okay? It can be made permanent. Sorry, I got to grab my balloon here. It can be made permanent by grounding it, but essentially think of it like this, okay? I've got this balloon here that is now covered in dog hair because it was on the ground. Gross. I'm going to clear that off real quick. All right, all good. All right, so when I rub it, So what just happened? What kind of a charge did I just do? Did I impart my electrons from my hair to the balloon from a distance? Or did I do it by directly contacting? Well, directly contacting, right? I'm directly contacting it. Now, there's all my hair all over the place, okay? Listen really carefully, okay? I'm going to turn my camera so you can see this, but I've got some paper over here, and on this, ignore that, on this paper is some salt. Listen really carefully. What happens is I bring the balloon close to the salt. Did you hear that? I'm not touching the salt, But if you look at the balloon now, I don't know if you can see. Yep, you can. There's all that salt. Okay, the electric charge is being transferred by induction. It's hopping from the paper to the balloon. Okay, now that it's directly touching the balloon, it's happened by conduction, and so these now have a charge because of the conduction, because of the actual touching of the balloon. My husband's gonna love the salt all over his office when he sees my mess. So that's induction, okay? Now, when we have that transfer where it goes from one thing to another, that's called current, okay? Current is the flow of charge from one place to another. And so that can happen by conduction or induction. Two ways: conduction, induction, current. Okay. So we're going to talk real quick about the difference between current and gases, liquids, and solids. And then we're done for the day, okay? And we'll talk about one more thing when we're done, okay? Gases aren't good conductors of electricity, okay? Air can conduct a current, but it's generally not a great conductor. But you might have seen it before, like, for instance, if you're laying in bed and you have a wool blanket or something and you pull it up and you see all these sparks fly. That's electricity being conducted through the air, okay? It's kind of like a bright spark that crosses a gap, okay? In liquids, we see this in electrolytes, electrolytic solutions, right? When we add the salt to the water, right, we can now conduct an electrical current through that liquid, okay? And you've seen, like, when we did the electrolysis lab in the Petri dish, remember, we added the current to the water and we saw the hydrogen and oxygen separating, okay? So electricity can be conducted through a liquid pretty well, which is also why you don't want to go swimming when it's, a lightning storm or anything like that. Or why you don't want to throw something that's got an electric charge into the pool you're in or the bathtub you're in, right? Because that electric charge can then be conducted to you, and that's not a good thing. And then the third is solids, okay? They can only flow through the movement of electrons from one atom to another in a solid. Okay, hold on. They occupy, that's because electrons occupy fixed positions. Or sorry, the electrons in the atoms occupy those fixed positions. So you can cause them to move, like I just did with my balloon and my salt. Okay. Now, there was a device that was created by William Gilbert. He was the guy we learned about yesterday, and he is credited with the invention of what we call an electroscope. And there's a picture of one on page 317 in your textbook. But essentially, it's a simple device that helps you to figure out if there's electrical charges. So what you do is you bring the whatever you're wanting to test, close to the device, and if it's got an electric charge, then the two little, kind of like, they look like leaves, little gold leaves, at the end will come apart if it has a charge, okay? Because the negative charge will cause it to have, both things to have a charge, and then they'll be repelled from each other. So when you see that repulsion, those leaves coming apart, then you know that there's an electric charge there. So it was just really a device to help you figure out, does this balloon have an electric charge or not? I have no idea. You bring it close to your electroscope, and then the leaves come apart, and you go, yeah, it's got electric charge. And if the leaves stay where they were, then there's no electric charge, obviously, okay? So that's what an electroscope is, okay? So shorter video today. You can have lots of fun with balloons and different, creating electric charges. I'm going to show you some more of those probably in our next video. But have fun with it, and let me know if you have any questions. Bye, guys.